exponential and logarithmic differentiation. And under this, these are just standard derivatives. You just have to know them. Y is exponential x, and then the y dx is exponential x. The derivative of an exponential function is the same thing, right? Exponential function and log, just like index numbers and logarithm numbers, right? That's the same thing with exponential and logarithm. This is the derivative of this is this, and then if y is equal to the x, the y dx is equal to 1 over x, and then the x is equal to log e to the base of e and of x. Now, the exponential function, the natural logarithm is the opposite or the inverse of exponential function. Just like when we have 2 raised to the power of 5 is equals to 32. If you want to write this is index form, you can start to write this as log 232 is equals to 5. Well, they are both saying the same thing, but in this case, this is index form as index numbers, right? Index form, and this is logarithm, right? So logarithm is just the opposite or the inverse of what? Index, right? In this case, we're trying to find 2 raised to the power 5 is equal to 32. But logarithm is trying to tell us what power you raise to get 32. So you just like the reverse and notice. In the same way, just like saying e to the power of x, right? This is the same thing as the x, right? In this case, we are talking about natural logarithm. So this is the inverse of this. So if you want to find this, you want to find the opposite or the inverse of this is what you use. And this one, as we wrote here, this is equal to logarithm of the base of e of x, right? So you can see that the same thing, e raised to the power of x is this, and then log ex, log 232 ex, right? So that's just the idea of, this is program called natural logarithm, right? Natural logarithm. This is called exponential x. So that's just the idea behind exponential and logarithm functions. But for the purpose of your exam, you just have to know this at the tip of your fingers. If y is exponential x, you have to know the derivative. If you have ax, where a is constant, so maybe something like 2 raised to the power of x, y is equals to 2 raised to the power of x. In this case, this one to come like this, e to the power of x, just know that this is the derivative. But in case where they give you a, where a is a real number, right, to the power of x, then the y dx equals to ax in x. So in this case, it's going to be what? 2 raised to the power of x ln 2, right? So that's just how it goes. If y is ln x, the y dx is 1 over x. So if they say find the derivative of ln 3, the derivative will be equals to 1 over 3, right? That's just the same thing with logarithm. You just have to know how to substitute your values in the standard derivative, right? So you solve some examples, giving something like this now. Y is equals to ln into x minus 4. This is just, it's not an absolute function, just in kind of a bracket, right? So you can see that in this case, now when you are solving exponential and logarithmic functions, just like when you are solving trigonometric functions, you just have to know the standard derivative. Then the way the question will come to be such that you can apply any of the rules of differentiation there, whether it's product rule, chain rule, quotient rule. Like in this case now, being x minus 4, you can see that merely looking at it, we're going to apply the chain rule. Why? Because it is not in the standard form. What is the standard form? The standard form is this. Y is equal to x, right? But we're not having that directly. We're having y is equal to x minus 4. So we have to apply the chain rule so that we can apply this. So applying the chain rule, what do we do? We set u to be equal to what? X minus 4. And then we can set y is equal to what? Ln u, right? So we can now find our du dx and our dy dx. And if this is the case, du dx will be equal to what? 1, right? The derivative of x is 1 and the derivative of x is 0. And then our dy du will be equal to what? 1 over u, according to our standard derivative. Ln x is 1 over x, ln u is 1 over u. 1 over what? U. Right? So multiplying both of them, what happens? You can see that the u dx multiplying this. So you can say the y dx now will be equal to what? 1 over u times which is what is our u? 1 over x minus 4 times 1 is the same thing. So this is our answer.